Students, today's goal, we want to be able to draw best fit lines. And before we even take any notes, let's look at a couple of graphs and we're going to try to predict what's going to happen with these graphs. So here along the y-axis, I have the number of hours that a group of students have studied. It ranges anywhere from 0 hours of studying to 10 hours of studying. And then on the y-axis, we have the scores that those students got on their test. Now, what kind of a correlation do you think there's going to be between these two variables? And I hope you say that you believe there's going to be a positive correlation. Let's look at the data. All right, as we look at this data, absolutely correct. There's a positive correlation here. You can see by this data. The more students study on the x-axis, the higher their test scores go on the y-axis. That's called a positive correlation. And you can always ask, well, how strong is that positive correlation? And I'd say this is from a medium strength to a strong strength. These don't make a perfect line by any stretch, but they definitely trend upward. Thus a positive correlation. Let's do another one. Down on the x-axis, the average traffic volume. So over on the left, the left-hand side would be no traffic at all, and the right-hand side would be like a traffic jam, wall-to-wall traffic. What's going to be the average vehicle speed? Think about this for a second. You guess in your own head, and I'm going to guess this should be a negative correlation. The more crowded it is, the slower you have to go. And when we look at that data graphed, it turns out that yes, indeed, it is a negative correlation. And I'd say this correlation is even a little bit stronger than the last one. It's not a perfect line, but it's a very strong trend. I'd call this, again, a medium to strong correlation. Okay, so this one, we have the amount of heating time. This is a pot of water on the stovetop trying to boil. Here's the number of minutes it's on heat. On the y-axis is our temperature. Yeah, this should be a positive correlation. The temperature should get higher as time passes. And if we look at this one, not only is this a positive correlation, but it is as strong as you can possibly get. It forms a perfectly straight line. That is called a 100% positive correlation. There is a perfect match. It makes a perfect line. So here we have on the x-axis the number of push-ups that a student can do, and compare that to the number of times that the student is absent. I don't know about you, but I don't think there's any correlation at all between these two events. And when we look at the data, that is played out. This is neither positive nor negative. It's a very weak correlation. Okay, and then here's the last one we'll look at. Here is the price that a concession stand is charging for a bag of popcorn. So like over here, it would be free, $0. Over here, maybe they're charging like $20 a bag. How many bags of popcorn are they going to sell, depending on the price? Well, if we look at this one's going to be negative. The more you charge for something, the less you're going to be able to sell. That is a negative correlation. And with that in mind, let's jump into the notes here.
All right, so at this time, I want to shift over to the notes, the specific notes we're going to take for this unit, for this goal, how to write best fit lines. And so hopefully you have this paper. You should receive this in class, or you can get it from me if you need it. All right, so here we have this scenario. There's a pizza food truck who they're experimenting with how much they want to charge for their pizzas, for their large pizza. Okay, and you can see here on the first day, they tried charging $10 for their large pizza, and they were able to sell 140 of them. On this second day, they lowered their price. They only charged $8 for the pizza, and they were able to sell 170. It went up. And then they just started experimenting around, lowering and raising the prices, and they kept track of how many they sold. Well, in a case like this, the independent variable, this would be the price that they're charging per pizza. This is kind of the variable that the food truck has control over. And that needs to go on the x-axis. Now the dependent variable, this would be the number of pizzas that they sold that day. The dependent variable always goes on the y-axis. If you think of this as a cause and effect, what we're trying to study is the cause would be as they change their price for each pizza, we want to study what is the effect that it has on the number of pizzas sold. Okay, so if you look at the graph, we're going to put the price per pizza on the x-axis. We're going to put the number of pizzas sold on the y-axis. Go ahead and plot these points. Ignore this red line for now, but go ahead at this time. You can hit the pause button if you need to. Go ahead and plot all 10 of these points, and let's see where we're at. So again, you're going to ignore this red line for now, but the next question is, does this have a positive correlation or a negative correlation? And as you can see from the points, that is definitely a negative correlation. The slope is going to go downwards. It doesn't make a perfect line, but it has a very strong correlation that the data is trending downwards. Okay, so now let's look at number 3. Number 3 talks about a best fit line. So what a best fit line is, we want to draw a line through these data points that fits as close to all of these data points as possible. So you can see I drew this red line here as a best fit line. And I feel like this red line falls in the middle of all of my data points reasonably well. A bad example of a best fit line, imagine if I drew my best fit line like this. Okay? That'd be a terrible best fit line because all my points are above the line. Or imagine if I drew my best fit line like this. That'd be a terrible best fit line because all my points would be under the line and they'd be really far away. What I did is just using, this is called visual estimation. I said I like this point right here, which is the 9,150. And I said I like this point right here, which is the 1492. And I said I like these 2 points because if I drew a line through those 2 points, it falls very closely to the middle of all of my data points. And this is visually how I can choose a best fit line. Now in number 3, what I'm going to do now is I'm going to take these 2 points that I determined visually, and now I'm going to write an equation of the line through these 2 points. There's 2 formulas you're going to need to do this. You're going to need the slope formula. This is something we've done in the past. You're going to need your slope formula right here. You're going to need the y equals mx plus b formula right here. If you need a refresher on this, go back and review our old lesson. This was called writing equations of lines. But hopefully with this example, since this is something that we've done before, you can pause this right now if you need to. Hopefully with this example right here, this will all come back to you. Ultimately, when we find the slope between these 2 points using the slope formula, we get negative 58 over 5. That's a negative 11.6 for our slope. And then when we plug our m value into y equals mx plus b, negative 11.6. And then we take our first x and our first y, and we plug those in for x and y here, the 9 and the 150. We're able to use that to solve for b, and we get a b value of 254.4. I actually went ahead and just rounded this to 254, and we're able to write this equation. So at this point, if you need to pause and kind of write down this example, you can. But let's go ahead and flip to the back now. So on the back of these notes, now what this equation is, I like to call this the pizza predictor equation. The idea is we've made this equation. We can plug any price into this equation. We can plug it in for x, and this equation will predict how many pizzas that our food truck will be able to sell on that day. So let's put this into practice. These essentially here are these x values. I want to know if I sold pizza for only $2 per pizza, how many would I be able to sell? Well, you would expect this number to be very high. If you were selling pizzas for only $2, you would expect you'd be able to sell a lot of them. And all I do is I just plug this $2 in for x, get out a calculator if you need to, okay, and it comes out that it'd be about 231 pizzas we would expect to sell at that low price. Okay, and that's a lot of pizzas to be able to sell. Now, of course, the problem is you're only getting $2 per pizza, so it's not like you're going to make a lot of money, but you would reach a lot of customers that way. And likewise, I'm going to go ahead and finish off the rest of this. I'm just going to plug these numbers in for x, and let's finish this off. And voila, here are our answers. If we charged our prediction, if we sold the pizzas for $15 a piece, we'd predict we'd be able to sell 80. If we jack the price all the way up to $20 per pizza, we predict we'd only be able to sell 22. Okay, so that's what our prediction equation came to us. Now, an important question, number 5, do you feel like your answers to number 4 are accurate in real life? Why or why not? Well, this is an opinion question. There's no way to get it right or wrong. I'll share my opinion with you. Our original data looked at Pizza's priced between $8 and $14. And so my opinion is this: we're the closer we are to this $8 to $14 range, I think our predictions are going to be pretty accurate. So like this $15 pizzas, predicting we'd be able to sell 80, I bet that's pretty accurate. On the other hand, the farther away you get from this range, the less accurate you're going to be. So I would question a little bit, like selling the pizza for $2 or selling the pizza for $20. There's a bit more variability. I would me personally, I would want to run some more tests in closer to that range before I'd really make a prediction. But you know, having these predictions is better than nothing. All right, on to question 6 and 7. So the slope of our line was a negative 11.6. What does that mean? Well, this has a very practical meaning. According to our prediction equation, we're going to sell 11.6 less pizzas in a day every time we raise the price $1. Okay, so if we want to raise the price of our pizza $1, that's fine. Just expect we're going to sell about 12 less pizzas that day. See, slope is rise over run. So slope always tells you how much is your y-axis, the number of pizzas, going to go up or down every time your x-axis goes over 1. So the number of pizzas goes down negative 11.6 when the price goes up 1. All right, and then question 7, what does the y-intercept tell you about this process? Well, the y-intercept, that always tells you the value of the y-axis when the x-axis is equal to 0. So in this case, it's saying we'd be able to quote-unquote sell 254 pizzas if we charged $0. In other words, if we gave this pizza away for free, the prediction is we would quote-unquote sell 254 of them. Okay. Now in reality, if you're giving pizza away for free, who knows? That's so unpredictable. Who knows what would happen? I would think you'd give away a lot. But who knows exactly what would happen? But that's what the equation is trying to tell us. All right. Now, in number 8, it gets a little trickier. Here, they're giving us all these y values. If our goal was to sell 200 pizzas in a day, how much should we charge per pizza? Well, here we're going to take this 200 and we're going to put it into y of our pizza prediction equation. So this one we have to work backwards. Now, we're going to put 200 in for y, and then we need to solve for x. So I'll show you on this real quick example, remind you how to do this. Here we would subtract 254 from both sides. Okay, and I'm going to start writing over here. We would get negative 54 is equal to negative 11.6x. And then we divide both sides by negative 11.6. Get out the calculator. And the calculator tells us if we want to sell 200 pizzas in a day, then we should consider giving a price point of $4, and I'll round to 66 cents. Okay, if we said, hey, we're selling pizzas for $4.66, the prediction is we'd be able to sell 200 pizzas on that day. All right, let me finish off the rest of these. And I just realized I did not give you a lot of room to work here, but here's what else we find. If our goal was to sell 100 pizzas a day, doing the math here, we should sell each pizza for $13.28. And if we want to sell 50 pizzas in a day, we'd want to raise the price. If we want to kind of lower the number we sold but sell it for more, we should charge $17.59 per pizza. Okay? And hey, before we end this lesson, I want to point out this is just one element of running a business, is choosing your price point. Another thing we'd want to consider next is, which one of these would bring in the most profit, right? Here, I'd sell a lot of pizzas, but my revenue would be smaller for each pizza. My profit per pizza would be way less, so that's something to consider. Whereas here, I'd be selling a lot less pizzas. I'd be bringing in a lot less customers, but I'd be making a much larger profit on each one. Okay, so that's kind of another thing to consider for another day. But for right now, this is still just a really helpful tool, helping us to predict how many customers we can expect and what our revenue would be. But after that, you'd have to consider, well, what's the cost per pizza? How much am I spending on supplies? How important is it to get customers in the door? All kinds of things. All right. So for number 9, we're going to switch gears. We're going to get on to Desmos. I'm going to show you on Desmos how to get a more scientific answer for your best fit line.
Number 9. So the method we used to come up with our prediction equation here, it wasn't too scientific. Okay, we came up with our prediction equation, our best fit line, really just kind of using visual estimation. Um, but here in question 9, it wants us to do it a little bit more scientifically using Desmos. So here's exactly what we're going to do. So on the Desmos calculator, I'm going to create a table by pressing this plus sign here and going to table. This is how I open up a table. And I'm going to fill in all of my data points into this table. Once I'm done with that, now I want to change my viewing window by clicking on the wrench in the top right corner. And I'm going to change my x-axis and my y-axis. So I want my x-axis to be, this would be the cost of what I'm charging for the pizza. And so I know I would charge anywhere from like $0 up to like maybe $25 or $30 for a single pizza. This is the price of a pizza. Okay. Now on the y-axis, this would be how many pizzas I expect to sell. And I know that this could be anywhere from 0 up to like 200, maybe 300 pizzas would be the most I could sell in a day. This is number of pizzas sold. Okay, and you can, there we go. That looks good. And then so you can see my scatter plot show up here on Desmos. And then once I have this entered in the table, and make sure my headings are X1 and Y1, I'm going to go below the table now, and this is what I'm going to type. Y1, and then a single squiggly line. And then I'm going to type MX1 plus B. And Desmos is going to draw its own best fit line through this data, and it's a little bit more scientific than what ours is. And you'll notice, according to Desmos, the best fit line, the slope should be negative 10.9, and the y-intercept rounds to about 246. So negative 10.9 y equals negative 10.9x plus 246. If you compare, this was done scientifically, doing what's called a linear regression test, and compare our slope. We found a slope of negative 11.6. Desmos found a slope of negative 10.9, but you know what? That's fairly close. And what's even closer than that, we found a y-intercept of 254. Desmos, a little bit more scientifically, came up with a y-intercept of 246. So I would say this prediction equation is better than ours. It's more accurate. But I give us kudos. For us doing just kind of an estimation, ours came out pretty well just by itself. Okay? And a couple other things I'll note to you real quick. So on Desmos, if I wanted to make any predictions on Desmos using Desmos's best fit line, I can actually slide to any price point I want. So if I want to predict like an $18 pizza, I can just slide here and say if I charge $18 for my pizza, I predict I'd be able to sell about 49 pizzas. Okay, likewise, I could slide here to like a $5 pizza. If I sold my pizza for $5 a piece, I predict I'd be able to sell about 191. Now, the last thing I'm going to point out here is this R squared value. Here you'll see this R squared value of about 90%, 90.44%. This tells you how strong the correlation is, how close this data is to being a perfectly straight line. It's about 90% strong, which is fairly strong. We would call this a quite strong negative correlation. The R squared value of 90% tells us that, yeah, that's a pretty strong correlation. Okay, so that wraps up these notes. Best of luck on your assignment. Take care. Bye.